Hi, my name is Mike Claron. I'm an engineer on the Android development team. Android is an open software platform for mobile development. It is intended to be a complete stack that includes everything from the operating system through middleware and up through applications. In the next few minutes, I'm going to be introducing you to an overview of the architecture of the Android platform, and I'm also going to talk about some of the key principles that are underlying its design. If we're going to talk about architecture, we need to start with a diagram covered with a lot of little boxes, and this is ours. Our architecture, we're going to start at the bottom and work up. Our architecture is based on the Linux 2.6 kernel. We use the Linux kernel as our hardware abstraction layer. So if you are an OEM trying to bring up Android on a new device, the first thing you do is bring up Linux and get all your drivers in place. The reason we're using Linux is because it provides a proven driver model, and in a lot of cases, existing drivers. It also provides memory management, process management, a security model, networking, a lot of core operating system infrastructures that are robust and have been proven over time. The next level up is our native libraries. Everything that you see here in green is written in C and C++. It's at this level where a lot of the core power of the Android platform comes from. I'm just going to go through and describe what some of these components are. I'm going to start with the Surface Manager. The Surface Manager is responsible for composing different drawing surfaces onto the screen. So it's the Surface Manager that's responsible for taking different windows that are owned by different applications that are running in different processes and all drawing at different times and making sure the pixels end up on the screen when they're supposed to. Below that, we have two boxes, OpenGL ES and SGL, and these two make up the core of our graphics libraries. OpenGL ES is a 3D library. We have a software implementation that is hardware acceleratable if the device has a 3D chip on it. The SGL graphics are for 2D graphics, and that is what most of our application drawing is based on. One interesting thing about the Android graphics platform is that you can combine 3D and 2D graphics in the same application. Moving over, we have the media framework. The media framework was provided by Packet Video, one of the members of the Open Handset Alliance, and that contains all of the codecs that make up the core of the media experience. So in there you'll find MPEG-4, H.264, MP3, AAC, all the audio and video codecs you need to build a rich media experience. We use FreeType to render our fonts. We have an implementation of SQLite. We use that as the core of most of our data storage. We have WebKit, which is the open source browser engine. That's what we're using as the core of our browser. It's the same browser that's powering Safari from Apple. And we've worked with that engine to make it render well on small screens and on mobile devices. Next is the Android runtime, and the main component in the Android runtime is the Dalvik virtual machine. The Android runtime was designed specifically for Android to meet the needs of running in an embedded environment where you have limited battery, limited memory, limited CPU. The Dalvik virtual machine runs something called dexfiles.dex, and these are bytecodes that are the results of converting at build time .class and .jar files. So these files, when they are converted to .dex, become a much more efficient bytecode that can run very well on small processors. They use memory very efficiently. The data structures are designed to be shared across processes whenever possible, and it uses a highly CPU-optimized bytecode interpreter. The end result of that is that it's possible to have multiple instances of the Dalvik virtual machine running on the device at the same time, one in each of several processes. And we'll see why that's important a little bit later on. The next level up from that is the core libraries. This is in blue, meaning that it's written in the Java programming language. And the core library contains all of the collection classes, utilities, I/O, all the utilities and tools that you've come to expect to use. Moving up again, we now have the application framework. This is all written in the Java programming language, and the application framework is the toolkit that all applications use. These applications include the ones that come with the phone, like the Home application or the Phone application. It includes applications written by Google, and it includes applications that will be written by you. So all applications use the same framework and the same APIs. Again, I'm going to go through and talk about what some of the main components are in this layer in the application framework. The Activity Manager is what manages the lifecycle of applications. It also maintains a common backstack so that applications that are running in different processes can have a smoothly integrated navigation experience. Next down from that is the Package Manager. The Package Manager is what keeps track of which applications are installed on your device. So if you download new applications over the air or otherwise install applications, it's the Package Manager that's responsible for keeping track of what you have and what the capabilities of each of your applications are. The Window Manager manages Windows. It's mostly a Java programming language abstraction on top of lower-level services that are provided by the Surface Manager. The Telephony Manager contains the APIs that we use to build the phone application that's central to the phone experience. Content providers are a unique piece of the Android platform. That's a framework that allows applications to share their data with other applications. We use that in our Contacts application so that all of the information in Contacts, phone numbers, addresses, names, is available to any application that wants to make use of them. And other applications can use that facility as well to share data. The Resource Manager is what we use to store localized strings, bitmaps, layout file descriptions, all of the external parts of an application that aren't code. I'm just going to touch lightly on the remaining 4 boxes: View System, Location Manager, Notification Manager, and XMPP Service. The View System contains things like buttons and lists, all the building blocks of the UI. It also handles things like event dispatching, layout, drawing. Location Manager, Notification Manager, and XMPP Service are some APIs that I think will allow developers to create really innovative and exciting applications. And the final layer on top is applications. This is where all the applications get written. It includes the home application, the contacts application, the browser, your applications. And everything at this layer is, again, using the same application framework provided by the layers below. Now, if you're going to write an application, the first step is to decompose it into the components that are supported by the Android platform. Here are the 4 major ones. We have Activity, Intent Receiver, Service, and Content Provider. An activity is essentially just a piece of UI, typically corresponding to one screen. So if you think of something like the Mail application, that would be decomposed into maybe 3 major activities: something that lists your mail, something that shows you an individual mail message, and a compose screen to put together an outgoing email. An intent receiver is something different. An intent receiver is a way for which your application to register some code that won't be running until it's triggered by some external event. And the set of external events that triggers your code is open and extensible. So you can write some code and through XML register it to be woken up and run when something happens, when the network connectivity is established, or at a certain time, or when the phone rings, or whatever trigger makes sense for your application. The next major component is a service. A service is a task that doesn't have any UI, that's long-lived, that's running in the background. A good example is a music player. You may start playing some music from an activity, from a piece of UI, but once the music is playing, you'd want it to keep playing, even if you're navigating to other parts of the user experience. So the code that's actually running through the playlist playing songs would be a service. That's running in the background. You can connect to it later if you want to from an activity or some other component by binding to the service and sending it messages like skip to the next song or rewind. The last component is a content provider, and again, that's a component that allows you to share some of your data with other processes and other applications. Now, any application can store data in whatever way makes sense for that application. They can store it in files, they can store it in our SQLite database, whatever makes sense. But if they want to make that data available as part of the platform so that other applications can make use of it, then the content provider is the solution for that. And we've used that for the contacts database that comes with the Android platform so that any application can make use of the information in contacts. Android was designed at a fundamental level to encourage reusing and replacing components. I have an example here that shows how that works. On the left, there are 4 applications that might want to pick a photo for some reason. So the home application might want to pick it for wallpaper. Contacts might want to pick a person's face to associate with their contact card. Gmail or MMS, you might want to have a photo that you send to someone in an outgoing message. Now in Android, for these applications to make use of the service of picking a photo, they first need to make a request. So the client component makes a request for a specific action. In this case, I'm illustrating that with a talk balloon, and the Gmail application is requesting that it picks a photo. So the talk balloon is actually a representation of a formal class in our system called an intent. What the system does when a request is made is it looks at all of the installed components and it finds the best available component that knows how to do whatever was asked for. In this case, let's say that the system finds the built-in photo gallery. Now, what happens is the Gmail application is now connected to the photo gallery. When the user in Gmail wanted to pick a photo, he will be taken to the photo gallery. The photo gallery will fulfill whatever was asked for in the intent. What makes this interesting is that the picking of the matching component is late bound. It's done very late, and so you can swap software components at any time. So let's say you didn't like the built-in photo gallery and you wanted to replace it with one that went online to find a richer or bigger set of photos. You could replace our built-in photo gallery with one that, say, goes out to Picasa or whatever your favorite online photo site is. Once you've done that, then any of the applications on the left will now use the new and better component on the right to fulfill the task of picking a photo. And at any time, a new application can come along and make use of existing functionality. So if you're writing a Blogger application, you don't have to worry about writing a photo picker yourself. You can just rely on whichever one the user has configured to be their preferred photo picking application. This becomes really important because in Android, it's not just about picking photos. Virtually any task has an intent in the middle. If the user is going from point A to point B, there's an intent in the middle, and each of those intents is an opportunity to reuse a component or to replace a component. So we have intents for going home, which means you can replace a home application, or we have an intent for sending an email, which means you can replace the mail application. All of these are opportunities for replacing and reusing components. If you're interested in finding out more about Android, I encourage you to visit the developer site and download the SDK. In the SDK, you'll find a lot more documentation and sample code, and you'll also be able to try building applications of your own. There's also a developer group that you can join to find out more information, and I also encourage you to check back frequently because we'll be posting updates to the SDK as the platform matures. Thank you for watching.